All right, ladies and gentlemen, here we go. Take out your notebook. If you remember yesterday, we did some volume problems. So let's continue with our volume problems. I'm going to open to the next blank page. I'm going to share my screen now. We're going to take a look at the quick review problem.
I am just recording it right now for some reason.
Okay, here we go.
Why is it recording?
All right, guys, here we go. Can you guys see that? Oh, everybody's. Miss Rackham, there you go. Miss Rackham, you're unmuted. Can you see my screen now?
Yeah. Yep.
All right, folks, here's what it looks like. Let's take a look at lesson 9 and the review problem. Can you guys see it, or do I need to zoom in a little? Here we go. Oh, isn't that nice? And it's auto-focusing. These 2 chips are for you, Carlos. Don't mind if I help myself. Can you still see my screen? Is this okay, Ms. Rackham? You can see the movement? Okay, here we go. So all you got to do for problem 1 is let's draw a number line. And so this is quick review. So do QR. And then just draw a number line nice and easy. Like so. And so. Right in the middle is 0, 1, 2, 3. Over to the left, remember, left. To the left is always negative, -1, -2, -3. Now, if you look right here.
It's not showing anything already.
You can't see it?
No. It's still a blank paper.
Oh, it's still a blank paper? Oh, how's that? Can you see movement? Why can't we see movement? Man, I tell you what, if it's not one thing, it's another. Do you see movement, Ms. Rackham?
Yep.
Okay, so do you guys see the number line? You see the number line, right? Okay, so if we zoom in right here between 0 and 1, we're just trying to get the scale on this. So I see 1, 2, 3, 4, 5. The middle dot is a little bit bigger, 6, 7, 8, 9, 10. So that means each one of these, since there's 10, each one of those is worth a tenth. So I just drew the number line. Let's take a look at point A. We're going to plot point A, and point A is negative the quantity -1 3/10. So if you remember negative numbers, whenever you see the negative sign, it means the opposite of. So what's the opposite of 1 3/10? So if you see a negative, it basically cancels it out because the opposite of negative turns both of these positive. All right? So we just need to plot 1 3/10. So we go over here to 1, and we go 1, 2, 3. So point A, 1 3/10 goes right there. Do you guys agree? Point B. Remember when you see these symbol, the 2 brackets, that means absolute value. So absolute value is always positive because what it means is the absolute value means the distance from 0. So negatives always turn positive because you can't have a negative distance. So now we're going to plot 2 3/5. But here's what's interesting. If you look at 3/5, we know that our number line is tenths, right? So we need to convert 3/5 to tenths. So luckily it's an easy conversion because 3/5 equals something over 10. What do you do to a 5 to make it into a 10? You multiply by 2. So we're going to multiply the numerator by 2, and we're going to get 6/10. So 2 and 6/10, we go over here to 2. We're going to go halfway would be 5, and then one more is 6/10. So here's point B. So on your number line, I forgot to show you here, A is just slightly 1/3 of the way between 1 and 2. Point A. Point B is just a hair beyond half between 2 and 3. Does that sound all right to you guys? Let's take a look at point C, 1 3/5. You already know that absolute value means distance from 0, so it's a positive number. So we're going to go 1 3/5. We know we already converted 3/5 over here, so 1 3/5 is the same as 1 6/10. So we're going to go to 1 and 5/10 and 6/10. So it's just to the right of A. So point C is right there. Next one, D is the opposite of -2.5. So the opposite of -2.5 is +2.5. So we go right up here, and point D is going to be right next to B. All right? So 2.5 is 5/10. So that's point D. Last but not least is point E, -1 and 1/10. So we're going to go to -1 and 1/10 would be really close to 1, but it's going to be on the other side of 1. Because remember, between 0 and 1, that's 1/10, 5/10, 9/10. -10/10 would be -1. So -1 and 1/10 would be just to the left of -1. And that concludes our quick review. So now let's talk about volume again. Can anybody tell me, does anybody remember? Because it says find the volume of this. And then also, folks, today you get to use your calculator, right? So pull out your calculator. And we're going to talk about example 1 here. So example, or actually that's just problem 1, right? So problem 1 is, hold this up here. Problem 1's an interesting shape. It's a complex figure, right? So everybody knows that volume, all that volume means is you're multiplying all 3 dimensions together. And what you get, so here's what problem number 1 looks like. So to calculate problem 1, there's 2 ways of going about it. So the first one is we can slice off the top layer. Can you see how that would work? If I slice off the top layer and it's 1 unit, then we multiply it by 20 to figure out all 20 layers. So that's one way of doing it. We would look at the top view. So if I just took this shaded portion, the orange part, we calculate the area of the orange part and then multiply that by 20. So let's take a look at that. I'm going to do that with that method first. So we've got, so picture top view. So I'm going to write top view over here. And so picture the top view, the orange section. So we're going to look at it straight down from the top. And it's going to look like this. So this part, it's like a backwards L, right? So this part is going to be right here. So we know that 9 inches plus 5.7 inches is going to be the same as this distance from here to here. So 9 inches plus 5.7, you guys have your calculator out. And this, Rackham, if you could start watching, if you could start watching the chat, then I will be able to look at this and do my calculations. So remember, take out your calculator. We're adding 9 plus 5.7. And that will give us this side right here of the orange guy. That's 14.7. So right here, I'm going to call this side right here 14.7. And we're going to go straight up and straight across the top because we're looking at it straight down from the top. This part right here is going to go 26. Then it goes up a bit. And it goes over. So can everybody see? We are now looking at the orange section right here. So here's the orange section. We just need to figure out this part right here is the same as this, right? So this part right here is 9. And this little part right here across the top is 5.7. This is 9.0, 5.7. Remember, type something into the chat if you have a question. So we're now looking at the top view. So all we do is we're going to calculate the area of the top view, and when we get that number, we're going to multiply that by 20 because remember, we have 20 layers across this thing. So picture it being split up into 20 layers. So we're just doing layer 1, which would be the orange part. So to do this, we remember last week when we had all these groovy shapes. Remember last week we had these guys and this guy. We had these really cool shapes, right? So we remember we just break it down into small pieces that we can wrap our arms around, if you will. So this part, I just drew a dotted line across here. Can you see this dotted line? That's this dotted line right here. They're the same. So we know that this is 16.5. From here to here is 16.5. So we're going to write 16.5 right here. So the area of this first part, which I'm now going to change its color. I'm going to change it to red. So now we're going to figure out how much is the red area. Does that help you guys? So then that means the red area represents this part right here. And remember, it's only 1 unit high. So you see how that represents this? 16.5 by 5.7 by 16.5. So everybody take out your calculator. We're calculating the red area. The area of the red equals, who's the first person? Can somebody, if you get it, you can type it into the, so we got 16.5 times 5.7. That's 94.05. 94. Sure is easy to do decimals on a calculator, isn't it? So 94.05. I'm going to hit clear. Now we're going to do the orange part, right? So we've got this orange part now, and that corresponds with the orange part right here. It's one layer. It's only layer 1 unit thick. So the orange part's right here. And the orange part's going to be 26 times, hey, look at the color. That orange is almost the same color as these delicious Doritos. Good. 26 times 14.2, 369. So the area of the orange is 369.20, right? Now what do we have to do, folks? Can anybody tell me what do we have to do next? Anybody? Anyone? Anybody out there? Okay. Well, we know that the red and the orange together, we need to add them, right? So let's just do that.
Alexa and Victoria say add.
So our total is 463. And I'm going to write that with the pencil, 463. 63.25. Sure is easy with the calculator, isn't it? Now remember, we just calculated this part, the orange and the red. Everybody see that? But that's only one layer. We still have 20 layers. So what are we going to do? We can either add this together 20 times, or something you guys learned a few years ago, that if you have more than one of something, you just multiply, right? So go ahead and multiply this by 20 with your calculator. Boom. We get a grand total of 9,265. So we know our total is 9,265. And then remember our units. Our units are inches. And we have how many dimensions over here? We've got a width, we've got a height, right? And we've got depth. So that's 3 dimensions. So our units are going to be in inches cubed. We also know that whenever we talk about volume, your units are always cubed. So this was one way. I called this like the layering method. We layered it 20 times, right, to find volume. But there's another method. So I'm going to fold my paper again, and we will do method 2 right now. I want you guys to look at this. Is there another way we can divide this shape? You guys see another way to divide the shape? Well, let's break it into, there's somebody on the chat? Okay, so Devin says we can add. Devin was saying add. Alexa said add. Good job, you guys. And Victoria, I'm recording this so that we can post it on YouTube for Miss Waggy's class. So I'm going to say hi to Miss Waggy's class. I'm glad you guys joined us. I'm taking out some colored pencils because we're going to do method 2. The second way of doing this is this. We could cut this into the red part, and then I'm going to continue using our 2 shapes. So we're going to do something where we calculate the volume of the red part, and then we also calculate the volume of the orange part. So there's 2 methods. Let's do the second method now. So I'm going to do this. I'm going to move this down. And this is pretty square looking. Let's see here. We've got, I'm going to try to draw the orange guy. So remember, we're leaving off the red part. We're going to talk about Mr. Orange guy right now. So he kind of looks like this. I think everybody can draw this pretty easily, right? And here's Mr. Orange guy. Can everybody agree that's Orange guy? We got 26 here. We've got 14.7 right here for Orange guy. And then we've got, we got 26. Oh, how tall is he? You know, he's 20 tall. So he's 20 from here to here. Right? 14.7 from here to here. And 26 across the front. Everybody see that? So now this is super easy. We're going to go like this. I'm going to actually log into my phone. We're going to hit clear. So we do 14.7. Grab your calculator. First person to type in the volume of Mr. Orange guy is going to win some Doritos from Mr. Glennon. 14.7 times 26 times 20. Anybody get it yet? Nobody's typed anything in. If I win, I get the Doritos. Boom, sorry. So, Orange guy right here, his volume is 7644, 7,644. All right, Alexa, good job, Alexa. And this is inches cubed again. So now let's take a look. We did Orange guy. Now let's try to draw Mr. Red. So the red guy's more of a perfect square on top. So I'm going to start with the top, and we're just going to go down, and we're going to go down here, and go down. He's going to go back a little. This is going to go back a little. Whoops. This is going to go back a little. Whoops. This is going to go down. Whoa! Woohoo! That's terrible. Orange guy. That is brutal. That is terrible. We're going to redo red guy. I don't like red guy. Strike that. Here we go. Let's try red guy again. More of a square on top. We're going to go straight down here, straight down here. There we go. That looks like red guy. Ooh, this camera is stiff. All right, there we go. So we're calculating red guy. We know red guy is 16.5 here. He's 20 tall because they're both 20. 16.5 across here, and then he's only 5.7 right here. So first person that could type in the correct volume of red guy. Here, let's cover up the other one with some Doritos. We don't want to look at that anymore. There we go. So, can you calculate the volume of red guy without being distracted by the Doritos? So, once again, take out your handy dandy calculator. Ooh, Alexa, Andrew.
311.
20 times 5.7 times 16.5, and we get, did I do it wrong? 20 times 5.7 times 16.5, and we get 1881. What did I do wrong? Let's try it again. Let's try it again. I don't know if I believe myself. 20 times 5.7 times 16.5. I'm sorry, folks. We got 1881. Nice try, Andrew and Alexa. I'm going to have to help myself to the Dorito.
I think you're frozen, Mr. Glennon. Oh.
Pardon me?
You're frozen.
Oh. Am I back?
A little bit. You're a little.
Okay.
Robotic.
1881 is the correct answer. There you go. Devin, you're off. 1,881. So red guy is 1,000 inches to the third power, or cubed, because we know volume is always cubed. But we need to add red guy to orange guy, right? So we've got 1881. And we remember up here that orange guy was 76.44. We get 1,261.26. So our answer is 1,261.26. Okay. I would like for you guys to type into the chat box, because my next question is, when we do problem 2, I want to know, do you want to do the layer method? Or do you want to do the method where we chop it into 2 different shapes and calculate the volume of 2 different shapes? Neither one is what Dexter says. I'm going to have to disagree with you, sir. Because we still have to solve the problem one way or another.
What's your preferred method, guys?
What's your preferred method? What do you chop it up? Alexa says chop it up. Since Alexa won before, I'm going to agree with her today. Problem 2 is brought to us by Roasters Coffee. Next time you're in Richland, please stop by your local Roasters and have a cold cup of hot coffee. All right, I'm going to use my straight edge. So we're going to chop this into, let's have a blue guy and a green guy, okay? Thank you, roasters, for joining us today. Okay, so we're going to have a blue guy. So let's look at the back part. It's going to be Mr. Blue. Okay, so don't worry, we'll draw Mr. Blue by himself. Can you guys see how I'm doing this? So really, we got a blue guy and we got a green guy. You guys see that? So we're going to calculate blue guy first. And we're going to get the green guy second. So back here, we're going to draw Mr. Blue. He looks kind of like this. Even though he's blue, he's not sad. He's just pretending. And does that look like Mr. Blue, kind of? We're going to draw this guy straight across. Was that hard to draw? I'm going to have to say no, it was not. So here's our blue guy. I'm going to take my trusty pencil. We know that blue guy is 14.8 feet high, so I'm going to do 14.8 right here. We know the blue guy is 4.3 right here, 4.3. And remember, our units are feet. But blue guy, 12.1 feet here, 12.1 feet here, and 18.8 feet. So we've got to add all that together. And I have a feeling it's going to be a nice round number. So type it in. If you know what 12.1 times 2, because there's 2 of them. And then we need to add 18.8. And I have a feeling it's a nice round number, 43. So Mr. Blue is 43 across the front. Okay, and remember our units are feet here. So this is super easy to calculate the blue guy. All we do is multiply those 3 numbers. You guys have your calculators out, so let's see if you guys can beat me. 14.8 times 4.3 times 43. Everybody get that? 2,736. So I'm going to write that right inside of the blue guy. 2,736.52. That's 14 times 14.8 times 4.3 times 43 across. Everybody see that? And these are feet. And it's cubic feet because it's feet to the 3rd power. And remember, because we have a dimension here 2, and dimension number 3 here. So we've got 3 dimensions: width, height, and depth. Okay? Now, everybody knows we did blue guy. We got to do green guy now. So let's draw the green guy. He's going to look a little bit smaller than Mr. Blue. Okay, was that hard to draw, Mr. Green? I'm going to have to say no, it was not. Not hard at all. So we got green guy. Now we got to label green guy. This is easy because he's 18.8 across the front. I'm going to use my pencil so we can actually read it. 18.8. We know he's 14.8 tall. And we know that he's 7 feet deep. So he's 7 right here. Super easy. Take out your handy, trusty, dandy calculator. Make sure you know how to log in though first. We're going to hit clear on this guy. We're going to calculate Mr. Green. 14.8 times 7 times 18.8. We get 1,947. And hopefully the Phoenix Suns know what 1,947 is. 0.68. All right. I'm going to double check my calculations. 14.8 times 7 times 18.8. Just to double check, 1,947.68, folks. All right. And somebody says that the Suns usually win 1,947 times. And I guess to have 0.68 of a victory would mean, Victorio, that game is still going on right now, and they have 0.32 of the full game left, right? Correct? Okay, here we go. One last step. We got to add the green guy to the blue guy. So first person that can tell me what that is going to win a prize, but I'm going to get him ready because I have a feeling that I might win again. I've been on fire since Alexa. Plus 1947. Ooh! Dexter and Alexa on fire. Wait, what are we doing wrong here, folks? Check your figures. 2736.52 plus 1,947.68 equals 4684.2. You guys were right, and Mr. Glennon was wrong. So I owe you a couple of Doritos. I'm gonna go ahead and eat these for you. They taste really good. They're regular Doritos. They're extra nice because Wonder Woman's on the package. And I want to thank you guys for participating. I'm going to hit stop on this right now. And we're going to go right down here.